Hello friends. In our previous lectures, we have already started with the topic called as simplex method. Now in that particular lecture, we have already seen how to transform a given linear programming problem into something called as a standard form. Now in this lecture, we are actually going to see what the simplex method is. In this lecture, we will see how to find the maximum or a minimum value of a given objective function. Now when I say all these things, objective function and simplex method and standard form, all these things have been taken in our previous lectures. All these concepts have been previously covered in the previous lecture. So make sure that you first go and watch all the previous related videos of simplex method so that this lecture can be well understood to you. So students, I welcome you all to this channel Pankaj Lade. Today's lecture will be entirely dedicated to find the maximum or the minimum value of a given linear programming problem. So in this session, let's begin with the first question where I'm going to take a problem on maximizing. Now, when I start simplex method, when I want to solve a given question with the help of a simplex method, there are a few important things that you want to take care of which the very first point that you should be noting down is a given linear programming problem should always and always be of maximizing type. Remember that a given linear programming problem should always be of maximizing type. If it is not of maximizing type, the first thing you should be doing is transforming the given problem into maximizing, and you know how to do it, isn't it? We put up a negative sign on both the sides of the maximizing functions. If minimize z is equal to is given to us, then what we do is we write z dash is equal to minus of z, we put a negative sign to all of the terms. So that is how we transform a given minimizing function into a maximizing function. So make sure that your first thing is that maximizing problem should be there. If it is minimizing, transform it to maximizing. The next important thing you should be noting down is your subjective functions should always have a right hand side which is non-negative. The right hand side of all the subjective functions. Second important point, the right hand side of all the subjective functions must be non-negative. That means either they can be all positive or they can be zero, but not negative. So that's the second point you should always take care of. The third and the most important point you should be remembering while doing simplex method is all the subjective functions. This is very important. All of the subjective functions should be of less than or equal to type. This is very important. So there are 3 points that I've discussed so far. The first point is the objective function should always be of maximizing type. The objective function has to be of maximizing type. The second important point that you should note down is the right hand sides of the subjective functions should always be non-negative. That means they can be either positive or they can be zero. Then the third important most point is the subjective functions should always be of less than or equal to type. If they are not less than or equal to type, then you have to transform again by adding a negative sign on both the sides to less than or equal to type. So if it is a greater than or equal to type, you should transform it to a less than or equal to type. So these are the 3 points you should always remember, you should always take care of while solving a question on simplex method. So all the rules should be always remembered, and we are going to apply those rules to start with the question. We are going to first of all transform the given problem, the given linear programming problem into a standard form. So make sure that you have already watched my videos on transforming a given LPP into standard form. So it will be very easy for you to understand this question also. So let's move ahead. The first and the foremost thing I should be doing is transforming this particular linear programming problem into a standard form. Now, I observe that the given question is of maximizing type. So the first worry has been taken care of, isn't it? I don't have to worry about changing it to a maximizing type. It is already given in maximizing type. The second important thing was the right hand side should always be non-negative. So they are all non-negative numbers. They are all positive. And the third and the most important thing was all the subjective functions should be of less than or equal to type. So they are of less than or equal to type. So I can observe that there are 3 inequations, isn't it? The subjective functions, if you remember, these are called as inequations. isn't it? Or we can call them as constraints. So these constraints are all of less than or equal to type, and then there are three subjective functions. That means I will need something called as three slack variables, isn't it? I will need something called as three slack variables. They are having something less, so they are in slack, so I'm going to add variables over there. So then these subjective functions, if needs to be written in the standard form, I can write them as, so the subjective functions now become x1 plus 2x2 plus x3 plus s1. So that's the first subjective function. So I need the first slack variable. So I've put up plus s1. Since there are two more subjective functions, two more slack variables are going to come. So I'm going to write plus 0 s2 and plus 0 s3 equal to, I write 430. So that's my first subjective function which has been transformed into an equality. Let's move ahead with the second one. So we have 3x1 plus, there is no x2 term here, isn't it? x1 is there, x3 is there, but x2 is not there. So I'll write plus 0x2 and then there is 2x3 plus 0 s1. Since this is the second subjective function, I'm going to write plus s2, isn't it? And then plus 0 s3 becomes equal to 460. So that's my second subjective function which has been transformed into an equality. Let's move ahead with the third one. Over here I can see there is x1 and then x2 is there, x3 is missing. So I can write here x1 plus 4x2 plus 0 x3, 0 s1, 0 s2 and s3, that is equal to 420. So that's the transformation of the subjective functions into what? The equalities. So that part has been done. Obviously I have introduced three slack variables over here, s1, s2 and s3. So I should be taking care of the non-negative constraints, calling them as x1, x2, x3. They are all greater than or equal to 0, and the slack variables s1, s2 and s3 also greater than or equal to 0. You remember that x1, x2 and x3 are called as the decision variables, whereas s1, s2, s3, these are nothing but the slack variables which have been added to the three subjective functions. Now you need to rewrite your objective function as well. So the objective function now can be written as, the objective function I'm going to write, it can now be written as z is equal to 3x1 plus 2x2 plus 5x3, and we have added three slack variables. So I'm going to write plus 0 s1, 0 s2 and 0 s3. So that is what we have transformed. That is how we have transformed a given linear programming problem into a standard form. So then what I can do here is, the next important point you should note it down is, write this equation somehow like this. I would write it like this: z, transfer all these terms on the left side, all the terms of the objective function which is on the right hand side should be transformed on the left hand side. So I get z minus 3x1 minus 2x2 minus 5x3. Now the next terms are 0s1, 0s2, 0s3. When they transform on the right hand, the left hand side, isn't it? So they will also become minus 0s1, minus 0s2 and minus 0s3. But as you all know, 0 and when you multiply with the negative sign, it is irrelevant, isn't it? The sign becomes irrelevant. So I'm going to keep it plus 0s1 plus 0s2 and plus 0s3. So that's not going to matter much, writing plus 0s1 or minus 0s1. So that is what you have done with the objective function. And now comes the real concept. Now you have to write the simplex table. You have to form a simplex table. Make sure that you note down all these things at the beginning, because as you can see, we have a limited amount of space to write all the steps here, and sometimes you might need to make 2 or 3 simplex tables. It can go ahead also, you can have to make, let us say, 4 or 5 simplex tables also. So depending on the question, the number of simplex tables can keep on increasing. Now over here I have first of all transformed the given linear programming problem into the standard form. So I'm going to write the simplex table now. So what this simplex table is, take a look very properly. Make sure, again I'm telling, note down the things. You are definitely noting down all the things in your book. Let's begin with the simplex table. Now in the simplex table, the very first thing that is going to be observed is something called as a basic variable. The first thing that we'll be noticing is a basic variable. So now I guess you remember what the basic variable is, isn't it? Basic variables are those variables which will have some value, isn't it? I'm going to take some value to those basic variables, and non-basic variables are those variables whose value I'm going to take as 0. So non-basic variables are those variables which will have value 0, and basic variables are those variables which will have some or the other value. So the first column will be of basic variables. The next thing that I will be writing over here is something called as the coefficients of all the decision and the slack variables which are involved in the subjective and the objective function. Next thing is the coefficient of all the decision and the slack variables which are involved in the problem. So I'm going to write here coefficient of. So the first variable I can see here is x1, then there is x2, then we have x3, s1, s2 and s3. So I have written all the variables which are involved in our question. So x1, x2, x3, s1, s2 and s3. So the coefficients of all the variables, either they are the subjective functions or it is the objective function. Next one is the right hand side of all the subjective functions, the right hand side of the inequations, or you can say the constraints. So RHS of all the constraints is the next thing that you should be writing, RHS. And the last column is going to be something called as a minimum ratio. Minimum ratio. Now what this minimum ratio is, do not worry about it. As and when the simplex table proceeds, you will come to know what all these concepts actually mean and why this table is written like this. Okay, so there is a basic variable. First of all, I'm going to write basic variable, then all the coefficients of all the variables involved, then the right hand side of the constants, and last one is something called as a minimum ratio. Now let's fill up the table. So I'm going to write here first of all Z. Let's write Z at the beginning, and then I'll put a dotted line here to differentiate this row from rest of the table. So let's put up a dotted line here. It is going to differentiate the first row from rest of the table. Okay, so now let's write all the coefficients here. Let us write all the coefficients from the second equation. So students are going to take the second equation, the objective function that you have written. You should be taking the second equation. So what are the coefficients here? X1 has coefficient -3. So let's write the coefficient of x1, which is -3. So I'm going to write here -3. What about x2? The coefficient of x2 is -2. So let's write -2. Then the coefficient of x3 is -5. Let's write -5. Then 0s1. So I'm going to write 0 over here. Then 0s2. So again write 0 coefficient and 0 coefficient. So I have filled up the first row. The first row has been filled up by the coefficients of all the variables involved in the objective function. Now there is no right hand side here, so I can write the right hand side, or you can say the right hand side can become equal to 0 because all the terms from the right hand side have been transferred on the left, so the right hand side got empty. That is why I am putting up a 0 over there. So let's write 0 over here. There is no minimum ratio in Z. Z does not have a minimum ratio. Now let's move ahead. I'm going to write some variables of all the subjective functions. Whatever variables you have for all the subjective functions, you take the coefficients of all of them and fill up the table here. So let's write all the coefficients from the subjective function. So what do we have? X1 has what coefficient? It is 1. See, X1 has coefficient 1. Then X2 has coefficient 2. X3 has coefficient 1. S1 has coefficient 1, then 0 and 0. So 1, 0, 0. Next one is 3x1. So I'm going to write 3 over here. Then 0x2. So let's write 0. Then 2x3. So write 2. Then 0, 1 and 0. So I write 0, 1 and 0. Next is 1, 4, isn't it? 0, again 0, 0 and 1. So now if you observe this entire table very carefully, you can observe over here a unit matrix, isn't it? See, there is a unit matrix 1 0 0 0 1 0 0 0 1. So this unit matrix is called as a basic matrix. It is called as a basic matrix. Now this is the matrix which have been compromised, which has been made with the variables S1, S2 and S3, isn't it? It has been comprised of S1, S2 and S3. These are the three variables involved into this particular matrix. The unit matrix has been made by variables S1, S2 and S3. So these variables S1, S2 and S3 in that particular order, because 1 0 0, 0 1 0 and 0 0 1, this order has to be maintained. The first S1, the first variable S1 gave me 1 0 0, the second variable gave me 0 1 0 and the third one has given me 0 0 1. So whichever variables will form this unit matrix or the basic matrix will contribute towards the basic variable. So S1, S2 and S3 in that particular order has given me the unit matrix. Hence I'm going to write S1, S2 and S3 as the basic variables. So who are the variables left now? X1, X2, X3 are left. These variables will now be called as the non-basic variables. So I'm going to write here that X1, X2 and X3 at this moment in the first simplex table, X1, X2, X3 have become the non-basic variables, and value of the non-basic variables is always taken as 0. So if I take X1, X2 and X3 as 0, these three terms will vanish from here. X1, X2, X3, I am taking them as 0. So these three terms will vanish from here. S1 becomes 430, S2 becomes 460 and S3 becomes 420. So those are the values of the basic variables at this moment. So this is what your simplex table would look like. Now students, you have to pay proper attention. I have noted down, or I have marked something called as a basic matrix or a unit matrix here. The remaining matrix, the remaining values are called as the body matrix. I'm going to call them as body matrix. Now my objective or my aim of solving this question is to find some values of x1, x2 and x3 which when substituted into the objective function will give us the maximum value, isn't it? I have to find the values of x1, x2 and x3 in such a way that when these values are substituted in the objective function will give us the maximum value. Now the value of z that is obtained at this moment is 0. This can be the maximum value. I don't know whether it's a maximum value or not. How do I confirm whether the obtained value of z, this is the value of z that I've obtained over here. So the obtained value of z, you can observe, isn't it? That is my objective function, and if I put x1, x2 and x3 as 0, because x1, x2 and x3 were my non-basic variables and their value I have taken as 0. So if I put x1, x2, x3 as 0, s1, s2, s3 I know is going to become 430, 460, 420, but their coefficient is 0. So when all these values are put up, the value of z came how much? It came 0. So this can be the maximum value, isn't it? I don't know. Who is going to tell me? It is being told by the row of z. Row of z will tell me whether I have reached at the optimum solution or not. Have I got the maximum value or not? Have I got the minimum value or not? Is told by this row. If there is at least one negative number present in the row, if there is at least one negative number present in the row of z, you have not reached at the maximum value. Very important statement, students. Make sure that you take a pen, a paper and note down this line in your book. I said unless and until you have at least one negative number present in the row of Z, at least one negative number is present, you have not reached at the optimum solution. You have to proceed further. You will have to make another simplex table. So here I can see there is -3, -2, -5. There are three negative numbers. That means the value 0 is not the optimum solution. I will have to go ahead. I will have to make one more table to get the optimum value of Z. Now, the next concept you should understand is something called as an incoming vector and an outgoing vector. There is some concept called as an incoming vector and an outgoing vector. Now, what's an incoming vector? How do I select my incoming vector? Now, incoming vector or the incoming variable is that variable which will have the most negative number in the row of Z. The most negative number in the row of Z. So this is the row of Z, isn't it? Who is the most negative number here? I can see there is -3, -2 and -5. 0, 0, 0 are irrelevant to talk about here. So the most negative number is -5, isn't it? -5 is the most negative number. You can observe it like this. You take the highest number with a negative sign. Highest number with a negative sign. So that's -5. So -5, or you can say x3 becomes your incoming vector. So I'm going to block this column here. So I block this column. So this column is called as the incoming vector. That means from these basic variables, someone will go and x3 will come. Someone will go from S1, S2 and S3 and x3 will come into one of the places from here. Now who is going to go from there? Somebody has to leave now. S1, S2, S3, someone has to leave and its place will be taken by x3. Now who is going to leave is decided by the minimum ratio. Now one thing I forgot is to write the right hand sides. I'm going to write the right hand sides here. So right hand sides are of the three subjective functions. It was 430, then 460 and 420. So now I'm going to decide who is going to leave from S1, S2 and S3. See, now I've decided who is going to come in, isn't it? S1, S2, S3, these were the basic variables. But taking S1, S2, S3 as the basic variables, I have not reached at the maximum value of Z, isn't it? So I need to replace S1, S2, S1, S2, S3 with one of the basic variables, with the new basic variables, which is going to come from x1, x2 and x3. So how did I realize which one is going to come? I have taken the most negative number from the row of Z. It was x3. So x3 becomes my incoming vector. Now if x3 comes in, somebody has to go, some variable has to go from here. So that can be now decided by the minimum ratio. So minimum ratio, the formula is xb upon xn. So xb is actually the right hand side. It is a right hand side of the inequation. So xb becomes the right hand side of the inequation and xn is your incoming vector. So this x3 at this moment is our incoming vector xn. So let's take the ratio of the two. Now while taking the ratio, this is very important. Again, note down this statement very properly. While taking the ratio from xb upon xn, you will ignore all negative ratios and those ratios which are going to give us an infinite value. While taking the ratio of xb upon xn, you will ignore those ratios which are going to give you a negative answer or an infinity answer. So this point has to be noted down very properly. So if you get a negative value over here or an infinity value, that particular ratio will be completely ignored while deciding the minimum value. Now, very important. If let us say all these ratios came negative, if these all ratios, the minimum ratios came negative, your linear programming problem will have something called as an unbounded solution. The problem cannot be solved further. Another very important concept, if you get all the minimum ratios negative, then you will get something called as an unbounded solution. So make sure you note down this point also very properly. So all negative values will be ignored, all infinity values will be ignored, and if all values in the minimum ratio came negative, then the solution is unbounded. You will have to stop the problem at that particular table. The problem gets over. So if all negatives come, then the problem gets over. You get an unbounded solution. So at this moment, I'm going to get xb upon xn. So let's see what xb upon xn is. So that's 430 upon 1, isn't it? 430 upon 1. So it's going to be 430. Then 460 upon 2. So I'm going to write 460 upon 2, that becomes 230, and then 420 divided by 0 is going to give me infinity. So no need to take the last ratio. The last ratio has been completely ignored because it came infinity. Now, as the name suggests, it is a minimum ratio. Minimum ratio, whoever has come the least value from here, that entire row, that particular variable will now be removed from the table. That means 230 is corresponding to S2. So S2 is the variable which is going to leave from the table, isn't it? So that becomes your outgoing vector. So this is your outgoing vector. So I'm going to mark this. This is your outgoing vector. So S2 leaves. S2 leaves. And who comes in place of S2? X3 will come. So outgoing vector. So far so well understood, isn't it? We will move ahead with the table, isn't it? We are going to make this table one more time. I'm going to erase these things and make this table one more time over here. Okay, so now we have seen so far how the first simplex table was made. So what we did was we have transformed the given linear programming problem into the standard form, and then we have made this table. So I made this table one more time. The first column is of basic variable. So the basic variable was decided by the unit matrix, or it is called as the basic matrix. So 1 0 0 0 1 0 0 0 1. The variables which were corresponding to the unit matrix S1, S2, S3, they were called as the basic variables. So they are written over here, S1, S2, S3. Then the most negative number from the row of Z, the most negative number from the row of Z becomes the incoming vector. That means from S1, S2, S3, someone has to leave. X3 will come into it inside this variables. Now out of S1, S2, S3, who will leave is decided by the minimum ratio, which was given by xb upon xn. Xb is nothing but the right hand side. Xn means the incoming vector. So 430 divided by 1, 460 divided by 2, 420 divided by 0. Whenever the minimum ratio comes negative or infinite, those ratios should be completely ignored. If all ratios come negative, then you get something called as an unbounded solution. So far so well, I guess you have all understood the things very properly. Let's now move on with the next simplex table. Now as I said, someone has to go, someone has to come in. S2 went out and X3 came in place of S2. So I'm going to make the simplex table one more time with the basic variable and all the coefficients as it is. So the first thing that I'll be doing here is, let's make the simplex table of which the first column is going to be the basic variable. So let's make the simplex table one more time. The first column is basic variable. Then you write coefficient of x1, x2, x3, S1, S2 and S3. Then proceed ahead with the RHS of the constraints, which is going to be XB, and then obviously you'll be getting again the minimum ratio, which is given by XB upon XIN. Now students, understand this. The incoming vector X3 here, isn't it? In our case it is X3. The incoming vector is now called as the key row, or it is called as the pivot row. This particular, this will be called as the key column, so this X3, the incoming vector, is going to be called as the key column, or it is called as the pivot column. The X3 column is now called as the key column or the pivot column. Likewise, the S2 row, the outgoing vector, is called as the key row, or you can say the pivot row, the key row or the pivot row. And the intersection of the pivot column and the pivot row, this particular element 2 is called as a pivot element. So 2 is called as a pivot element, or it is called as the key element. So either you call it as a pivot element or you call it as a key element. This element has to be 1. Very important point, please note it down. The intersection of the key column and the key row is called as the key element or the pivot element. This element has to be 1. So here it is 2, I have to make it 1. So this can be made 1 only and only by dividing this entire row by 2. I am going to divide the entire key row or the pivot row by 2, so that the pivot element becomes 1. So I am going to divide this by 2. So let's divide by 2, and S2 has gone. Who has taken the place of S2? X3 has taken the place of S2. So I am going to write here, the first one is S1, S2 leaves, X3 comes in, I write X3, and then there is S3, so I'm going to write S3. So who's the first basic variable? S1. So S1 has to be 1, 0, 0. So I'm going to write here, first of all, Z obviously is going to come. So we'll be writing Z also, isn't it? Let us put up a dotted arrow here, a dotted line here. Then we have S1, S1, and then S2 has gone out and X3 has come in. So I'm going to write X3 here, and then S3 we have, so write S3 over here. So now at this moment, this 2 has to become 1. This entire row needs to be divided by 2. So I'm going to divide by 2 here. So I get 3 by 2, 3 by 2, isn't it? Then 0 divided by 2 is again 0. 2 divided by 2 will get 1. 0 divided by 2 you get 0 only. Then 1 divided by 2, so I get 1 by 2 here. And then 0 for the next element. And 460 gets divided by 2, you get 230. That's your new row now. New row of S2, which has become X3, because S2 has gone out, it has left, and its place has been taken by X3. So this is the new row for us. Using this element, now observe, I have the first basic variable as S1. So the column of S1 has to look like 1, 0, 0. That is why it is called as a basic variable. So 1, 0, 0. Then there is x3. So x3 should look 0, 1, 0. That means I have already got 1 here. What I need to do more is make the other two elements also as 0. So s1 was first, so 1, 0, 0. Then there is x3, so 0, 1, 0. And then lastly it is s3. It is going to be 0, 0 and 1. It has to form a basic matrix, and that is why the variables will be called as the basic variables. So now my next job is to make these two elements as 0, isn't it? That means this one has to become 0 and this 0 has to become 0, but since it is already 0, there is nothing to worry about the last row. So let's write the last row directly because it is already 0 here. So I'm going to write the last row. It is 1, 4, 0, 0, 0 and 1. So I've written the last row, and now what I need to do more is make this one as 0 using the help of the new row here. The new row, this is the new table here, isn't it? So in place of this 1, what I need is, I need 0. So I'm going to take the help of this element, the pivot element, which has been transformed into what? It has transformed into 1. It is here. This is, I'm going to write here R1, R2 and R3. So this is R2, the new R2 here. So remember the second row is here now, it is not here. So I'm going to remove R2 from here. So what I need to do to make this element as 0, this is 1. It is R1, the first row. So I'll do R1 minus R2. So I'm going to do R1 minus R2. So I get this is 1 minus 3 by 2. 1 minus 3 by 2 because I'm doing R1 minus R2. I am doing R1 minus R2 so that this element 1 becomes 0 because second basic variable was x3. It has to look 0, 1, 0. So I have to make this element as 0, but it was 1 here. So 1 minus 1 I can get 0. Hence the row operation R1 minus R2. Okay, so 1 minus 3 by 2. I get minus 1 by 2, isn't it? Then there is 2 over here and then there is 0 over here. I'm going to do R1 minus R2. So 2 minus 0, I get 2. Then 1 minus 1, I get 0, isn't it? Then 1 minus 0, I'll get 1 here. Then 0 minus 1 by 2, I'll get minus 1 by 2. And then 0 minus 0, I still get 0. Now do you observe the first variable is S1. Take a look at the column of S1. It is 1, 0, 0. Then the next is X3. It is 0, 1, 0, isn't it? And the last one is S3. It is 0, 0, 1. So are they again forming a basic matrix? That is why these variables are called as the basic variables. They have to make the basic matrix. So this is how I've got so far. Now there is one more row left, isn't it? I'll do this minus 5 also. I'm going to transform into 0. So I'm going to do here one more row transformation, changing the minus 5 also to what? 0. Now I'm going to call this as R0. This is the initial row. So I'm going to call this row of Z as R0. So what I need to perform here is this minus 5 and here it is 1. So I want to do R0, which is minus 5, then plus 5 into R2. So remember, this is R0 here and then R2 is here, and I want to do R0 plus 5 times of R2. So what's the value here? It is minus 3. What's the value here? It is 3 by 2. And what you are doing? R0 plus 5 times of R2. So minus 3 plus 5 times of R2, which is 3 by 2. So I'll done 3 by 2 here. So that gives me minus 3 plus 15 upon 2. You cross multiply. Minus 3 into 2, that gives minus 6. 15 minus 6 is 9 upon 2. So I've got the value here 9 upon 2. So you need to make all elements, rest of all elements as 0 from the incoming vector. So this was 1, it was made first 1, and taking the help of this one, all other elements should become 0. Come to the next one, it is minus 2. So I'm going to write minus 2 here. Next value is minus 2. So let's write minus 2 here. Then I'm doing R0 plus 5 times of R2. So plus 5 times of. What is the value of R2? It is 0 here, isn't it? So into 0. So it remains minus 2. Then minus 5 and plus 5. Obviously it is going to become 0. This is what element I have taken to write the row operation, isn't it? So that became 0. Then here 0 it is. So R0 is 0 plus 5 times of R2, which is also 0. So S1 still remains 0. S2 is again 0. So you write 0 plus 5 into R2, which is 1 by 2 into 1 by 2. So I got here 5 by 2. And finally S3 it is 0. Here also it is 0. So I'm going to get 0. Students, I hope you already know the elementary row transformation. You have already learned matrices in your previous standard. So I hope these calculations are not very difficult for you that I'm doing over here. So this is what I have got, the next simplex table. Okay, let's come here also, getting the value over there. So I'm going to get here, see, I did R0 plus 5 R2. R0 is 0, isn't it? It is 0 plus 5 times of R2, which is 230. It is 230, isn't it? Here the value is 0 and then 5 plus 5 into R2, which is 230. So if you multiply this, you get 0, 5, the 15, carry 1, 10 and 11, 1150. So 1150 is my next optimum solution. It can be the optimum solution, I don't know, isn't it? Who is going to tell me whether I have reached the optimum solution or not? So if all values here became non-negative, all values in the row of Z, if they have reached non-negative values, if everybody is positive or 0, then you have reached the maximum or the optimum solution. But did you observe the row of Z? There is still one number which is negative, isn't it? That means until now I have not reached the optimum solution. I will have to go ahead. I have to proceed with one more table. And how do I proceed further? How do I decide now the incoming vector? The most negative number will become the incoming vector. And who is the most negative number here? It is minus 2. So I have recognized that this row, this column of x2 is going to be my incoming vector. So x2 comes in, it becomes the incoming vector. I'm going to call it as x in. If x2 has to come in, somebody has to leave. Either S1 or S3, somebody has to leave. And who will decide? Who is going to decide who has to leave? It will be decided by the minimum ratio. Now let's work out the other values also. Now what we have done here is S3 was written as it is, so I'm going to write 420 here as it is, no change in this value. And I did R1 minus R2, so that was 430, isn't it? Minus of R2, which was 230. So 430 minus 230, I'm going to get 200 at this place. So I've written all the right hand sides, isn't it? I've changed according to the row operations. Now I'm going to get the minimum ratio. So to get the minimum ratio, what do? I take XB, I take X in and I divide it. If you get negative value, it will be discarded. If you get a infinity value, it will be discarded, isn't it? You have to take the positive value and that to the least value. So it's 200 divided by 2. So 200 divided by 2, you get 100. Then 230 gets divided by 0, that's infinity. So no need to take this value. And 420 divided by 4. So if you divide 420 with 4, you get 420 divided by 4, you get 105. So who's the minimum value at this moment? 100 and 105, these were the two values, xb upon xin. So the minimum value is 100. That means S1 has to leave. And who will come in place of S1? X2 will come in place of X1. So this becomes my outgoing vector, isn't it? This S1 becomes my outgoing vector. So that's your outgoing vector. So I'm going to write here outgoing vector. So far so well understood, everyone, isn't it? So This is the outgoing vector, this is the incoming vector, or you can say this becomes the key column or the pivot column, this becomes the key row or the pivot row, and the intersection is nothing but what? The intersection becomes the pivot element, and the pivot element should always be 1. So my next job is to make this 2 as 1, and it can be achieved only by dividing this entire row by 2. Now as you can see, I have to make one more table here, so I'm going to wipe out this entire thing from here. I'm going to make one table, so I'm going to rewrite this table over here, and then we will proceed further. So let's see how this can be done. So students, I have made the second table, the second simplex table, the second iteration. One more time, if you remember, if you have noted down the things very properly, then S1 was the outgoing vector. And why it is outgoing vector? Because you have got the minimum ratio for S1. So S1 leaves, and who comes in place of S1? X2 is going to take its place, isn't it? So my new basic variables are going to be X2, X3 and S3. So I'm going to write here the new basic variable. The first one is going to be X2 now. Next would be X3, because S1 is going to leave, other variables remain same, and then there is S3, isn't it? Now the first variable is X2. So X2 should look 1 0 0. Then there is X3. It will look 0 0 1, and then S3 it will look 0. Sorry, X2 is the first variable, so 1 0 0. X3 is the second variable, so 0 1 0, and S3 is the third variable, so 0 0 and 1. It has to look like a basic matrix. So now let's begin. I'm going to write X2 first. So S1 has left, isn't it? S1 has left, and its place is to be taken by whom? X2 is going to take its place. What is the key element over here, or the pivot element here? It is 2, but it has to be how much? This element has to be always and always 1, isn't it? So I'm going to make this element as 1. And how can I achieve it? How I'm going to make this element as 1? I can divide this entire row by 2. I will get the value here as 1. So let's divide this entire row by 2. So my answer is going to be here minus 1 by 4. Okay, so I need to write Z also. Sorry for that. Let's write first of all Z. So I'm going to write here Z separated with a dotted line or the dashed line, isn't it? And we'll keep it aside. Then the next was S1 has gone out and X2 has taken its place. So X2 is going to come. Then there is X3, and finally you will have S3. So X2, this 2 element has to become 1. I'm going to divide this entire row by 2. So my first number is minus 1 by 4, because minus 1 by 2 gets divided by 2. It becomes minus 1 by 4. 2 gets divided by 2, you get 1 here. 0 upon 2, you get 0 here. 1 divided by 2, you get 1 by 2. Next value is minus 1 by 4. Next value is 0 divided by 2, that's going to be 0. And 200 gets divided by 2, you get 100 here. So that's your next row. So that is going to become, now I'm going to call it as R1, isn't it? That's R1. This is R2 and this is R3. Now my next job is to make the other 2 elements as 0. So this element has already become 1. Other 2 elements has to become 0. I can see that R2 is already 0 here. So there is no need to change R2, isn't it? Let's rewrite R2 as it is. So I'm going to write here 3 by 2. Next is 0, because once this element becomes 1, taking the help of this element as 1, we have to make the other 2 elements as 0. So I'm writing here 0 because it's already available. Then 1, 0, 1 by 2, 0, and you write 230 also. Now you have to definitely change this element, isn't it? Here it is 4, you have to make it 0. So what can I write here is this R3. So I'm going to write R3 minus, that's 4 here. So I'm going to write 4 times of whose help I'm going to take the pivot element, which has become 1 now. R1, R3 minus 4 R1. So what's the value of R3 here? It is 1 minus 4 times of, what's the value of R1? Minus 1 by 4. So R3 is 1 minus 4 into R1 is minus 1 by 4. Minus 1 by 4. So 4 and 4 cancels. You get minus 1 becomes plus. 1 plus 1 you get 2. So I'm going to write 2 over here. Got that? So this is 2 here. Then that's 4. So obviously 4 minus 4 is going to become 0. So I'm writing 0 over here. Next value is 0. So R3 is 0 minus 4 times of R1 is 0. So 0 minus 4 into 0. I'll get 0 here. Let's move ahead. Then again I have 0 here. So I'm going to write R3 as 0 minus 4 times of R1 is 1 by 2. So 1 by 2, the answer comes minus 2, isn't it? 4 and 2 cancel, 0 minus 2, you get minus 2. The next value of R3 is 0, so I'm going to write 0 here. Let's remove this. 0 minus 4 times of what's R1? It's minus 1 by 4, minus 1 by 4, so 4 and 4 cancels, minus minus becomes plus, so you get 1 here, isn't it? 4 and 4 cancels, minus minus became plus. So you get 1 here, and the last value it is 1 here, minus, you are doing R3 minus 4 R1, so that's 1 minus 4 into 0, it still stays 1. So now if you observe, your first basic variable is x2. If you take a look at x2, see what has happened. 1 0 0. The next basic variable is x3, 0 1 0, and the last one is s3, 0 0 1. So these three basic variables are forming a basic matrix. It has to happen. That is why they are called as the basic variables. Now this one last row is left. Okay, this element is left. Let us change that also. What we have done is R3 minus 4 R1. R3 is 420. So I'm going to write 420 minus 4 times of what's the value of R1? R1 is 100 here, isn't it? So minus 4 times of 100, you get 400. So 420 minus 400, that gives me 20, isn't it? So let's remove this calculation from here. So that's 20 over there. Now I also need to change Z. I'm going to call it as R0, isn't it? R0. What is the value over here? It is minus 2, isn't it? This minus 2 has to change. It has to become 0. So what I need to perform here is R0, which is minus 2, plus 2 times of R1, isn't it? Plus 2 times of R1. So let's do it very carefully. R1 is here, R0 is here. So that's first number 9 by 2. So I write 9 by 2 plus 2 times of R1, which is minus 1 by 4. I write minus 1 by 4 here. So that's 9 by 2 minus 2 and 4 cancels. You get 1 by 2. 9 by 2 minus 1 by 2 became 8 by 2, which is 4. So I've got the first positive value, isn't it? So I'm going to write 4 here. Let's move ahead. It's minus 2. Obviously, it's going to become 0 because this is the element which has been used to write the row operation. Remove the calculation. That's a rough work. Let's move ahead. You have 0 over here, isn't it? R0 is 0. Put 0 plus 2 into R1 is also 0. So you get 0 here. Next is 0. So write 0 plus 2 into 1 by 2. That's going to become 1. You have to take care of the calculations. Then the next value is 5 by 2. So write 5 by 2 plus 2 times of R1 is minus 1 by 4. So write minus 1 by 4. So that gives me 5 by 2. And it becomes minus 1 by 2. So 5 by 2 minus 1 by 2. That's 4 by 2. So that will give us 2. Another positive value. And finally 0 here. And 0 here also. So I'm going to get last value as 0. And finally this number I'm going to get from here. It is 1150. R0 is 1150, so add 1150 plus 2 times of R1. So R1 is 100 here, isn't it? You have to take care. R1 is 100, R1 is here. So 1150 plus 2 into 100. So that becomes 200. So 1150 plus 200 will give us 1350. Now can this be the maximum value? Can this be the maximum value? For that I have to check whether I need to proceed further. Isn't I have to make a simplex table or not? And how can I go further? If there is at least one negative value present in the row of Z, at least one negative value of Z present, isn't it? Then I have to make one more simplex table. So at this moment I see there is no negative value in the row of Z. That means the value that I have reached 1350 is definitely what? It is definitely the optimum solution. This is the optimum solution, isn't it? So I've got the optimum solution. So the optimum solution came how much? The optimum solution has come 1350. So 1350 is nothing but the value of Z, the maximum value of Z. So once I reach up to the maximum value of Z, I now know the maximum value of Z is been obtained 1350. But for what values of x1, x2 and x3? These were my decision variables. x1, x2 and x3 has to come from somewhere. They are going to be obtained from the same column. The same column of right hand side of the constants is going to give me the value of x1, x2 and x3. Come back to the column of basic variables. Do you find x1? No, I do not see x1, isn't it? x1 is not present. That means the value of x1 is going to be 0. The value of x1 is going to be 0. Do you see x2 in the basic variables? x2 is there. What is the corresponding value of x2? It is 100. So I can write x2 is 100. So x2 came 100. And finally I'm going to write the value of x3. So x3, again you go to the column of the right hand side, the column of the xb. It is how much? x3 corresponding value is 230. So you write 230. That's your value of x3. That means, students, we had an objective function. Now I hope you have noted down the entire solution in your notebook. So you already have the objective function. Go back to the objective function and you put the value of x1 as 0, x2 as 100 and x3 as 230 in the objective function. You will definitely end up with the answer as 1350, which is the optimum solution of the given objective function. So students, this is how we solve a simplex table. I know the question is too lengthy, isn't it? But we have to understand it. We have to understand how the things happened over here, what steps we have taken care of. So remember, there are only few things that you want to remember while doing or while solving a problem on simplex method. The first thing is that the objective function should always and always be of maximizing type. The second thing, all the right hand sides of the inequations should be non-negative. That means they can be either positive or 0. And the third and the most important thing is all the subjective functions has to be less than or equal to type. Only then you can solve the particular question by using the simplex method. Now once you know the methods, once you know all the steps, then it becomes quite easy. It is all just calculations. You have to just be very patient, very calm while solving question, because if you do any mistake in any of the steps, it will be very difficult to rectify the mistake. So make sure that you watch this video again and again to understand the simplex method very thoroughly. So students, I'm going to leave you over here, but in my next lecture, in my next session, we will continue, or we will take one question on minimizing also, isn't it? So in this session I have taken a problem on maximizing. I will definitely make one more video on minimizing, and then one more session I'll take just to understand the varieties of different problems. So students, I'm going to leave you here. Thank you so much for watching. Make sure that you do your practice very properly. Have a great day ahead.